All right, this is Unit 3, Lesson 7, Transformations of Polynomial Functions. Our lesson essential question is, how are symmetry and transformations represented in the graph and equations of a polynomial function? At the end of this lesson, you'll be able to identify symmetry in and transform polynomial functions. All right, so concept, odd and even functions. A polynomial function p of x equals a sub n x to the nth plus a sub n minus 1 times x to the n minus 1 plus continued a sub 1 x to the first power plus a sub naught is an even function if it is symmetric about the y-axis, and an odd function if it is symmetric about the origin. Other types of functions can also be classified as odd or even. So for example, the function y equals the absolute value of x is an even function. So I can see my even functions, they're symmetric about the y. Okay, so basically if I have a point here on the y-axis, it's an even function, it'll be symmetric about the y. For odd functions, it's symmetric about the origin, so that means I can rotate this function and it stays the same. And then neither, so this is not even or odd. So for all x in the domain f of x equals f of negative x, so I pick a point x and it will have a point negative x. So if it were 3, for example, this would be negative 3. Okay. For all x in the domain f of negative x equals negative f of x. So f of x gives me negative f of x. And then if it's neither, f of 1 does not equal f of negative 1. Okay. It doesn't equal the same thing. So it's not even and it's not odd because f of negative 1 does not equal negative f of 1. All right, example number 1. Identify even and odd functions from their graphs. So if I'm looking at this function, it looks like it's symmetric about the origin. So what happens when you reflect the graph across the x-axis? So there's a reflection. New graph is not even. Okay, and what happens when you rotate the graph 180 degrees about the origin? It's the same graph. See here, rotation or reflection. Okay. Now if I rotate it 180 degrees, it gives me the same. So there it is, about 90. Okay. So if I rotate it 180 degrees, it gives me the same points. So that means it's an odd function. Okay, so I can also test 2 points. So test points to confirm 1, 1. And negative 1 are both on the graph, so this function is odd. Okay. Use the graph to classify the polynomial function. Is it even, odd, or neither? So if I rotate it 180 degrees, I get that. And if I reflect it across the y, shows me it's an even function. Okay, I can also test points 1, 2, and negative 1, 2. They're both on the graph, so the function is even. So use the graph to classify the polynomial function. Is it even, odd, or neither? So if I reflect, here's my reflection. Okay, so it doesn't match up. Here's my rotation. Also doesn't match up. So this is neither even nor odd. Okay. So I can test a point. Okay, so here's, okay, so I can test a point to confirm 1, 2 is on the graph, but negative 1, 2, which is right here, is not. And negative 1, negative 2 is also not. So it is neither even nor odd. Okay. So classify it. Classify the polynomial function as even or odd based on the graph. Use the sliders to reflect and rotate the graph, then classify the function. Okay, so looking at this, it looks like an odd function. If I reflect it, you can see that nothing matches up. The points don't match up. Okay. If I rotate it, it's going to be the same graph. You can see that this point, these 2 points are the same. Okay. So this is an odd function. Okay. All right, so I want to classify this polynomial. So let's look at the rotation first. So if I rotate it 180 degrees, it gives me this point right here. Okay. And if I reflect it, it gives me the same point. So this is an even function. All right, example 2 is the function odd, even, or neither. I have 4x to the 4th plus 5. So if I substitute in negative x into this, I should get the same answer. So 4 times negative x to the 4th plus 5 gives me 4x to the 4th plus 5. So this is an even function. Okay. All right, so B, g of x equals 2x cubed plus 3x. So if I substitute in negative x here and I get the same thing, I know it's even. Okay, so I get negative x cubed is negative 2x cubed minus 3x. So that's negative 2x cubed plus 3x. So g of negative x equals negative g of x, so it's an odd function. All right, so let's try it. Function odd, even, or neither. So I'm going to substitute in negative x. So I get 7 times negative x to the 5th minus 2 times negative x squared plus 4. Okay. So when I do this, I get negative 7x to the 5th plus 2x minus 2x squared plus 4. Okay, so this doesn't give me, so f of negative x does not equal negative f of x. Because I can't pull out a negative. If I do that, this would be, it wouldn't actually work. Because if I substituted out, if I pulled out negative 7x to the 5th plus 2x squared minus 4, which isn't the same thing as this. Okay, so it's not odd, but it's also not even because not everything stayed the same. So this is neither. Okay. So I have x of x equals x to the 6th power minus 2. So I'm going to substitute in negative x. I have negative x to the 6th minus 2. So this gives me x to the 6th minus 2. Nothing changes, so this is an even function. All right, example 3. How does the transformed graph compare to the graph of the parent function? I have g of x equals 3x to the 4th minus 18. Okay, so identify the transformations. So 3x to the 4th minus 18, that's g of x. The parent function is y equals x to the 4th. So the leading coefficient stretches the graph vertically, making it narrower than the graph of the parent function. Okay, so it stretches vertically. And then a vertical transformation, subtracting 8, translates the graph 8 units down. Okay, so the leading coefficient stretches it, makes it narrower, and then minus 18 tells me that I move it down 18 units. How does the transformed graph compare to the graph of the parent function? H of x equals 5 times the quantity x minus 2 cubed plus 4. Okay, so I know this 5 is going to be important, this -2 is going to be important, and this 4 is going to be important. Okay, so identify the transformations, the 5, the -2, and the 4. Okay, so the parent function is y equals x cubed. That's this blue one right here. Okay, the horizontal translation, okay, so that -2 means that I'm moving it 2 units to the right. Okay, so I moved it 2 units to the right. The leading coefficient tells me I stretched it. Okay, so it makes it narrower. And then I have a vertical translation of up 4. Okay. So how does the graph of the function g of x equals 2x cubed minus 5 differ from the graph of its parent function? So the parent function is f of x equals x cubed. Okay. The 2 stretches the function, and I move the function down 5 units. Okay, so it stretches, and this is a vertical stretch. All right, example 4, identify a transformation. So the given graph is a transformation of the parent cubic function or parent quartic function. How can you determine the equation of the graph? Since the ends extend in opposite directions, the end behavior shows that the parent function has odd degree. Okay, so I go up and down. Okay, the end behavior indicates a negative leading coefficient, so this graph is a reflection such as y equals -x cubed. If it weren't, the graph would be going from down to up. The point 0, 0 has been shifted to -3, -1, which shows that this graph's been translated. So it's moved 3 units to the left and 1 unit down. So that's 3 units to the left, so +3, and then 1 unit down, -1. So the function is negative x plus 3 cubed minus 1. So the given graph is a transformation of a parent cubic function or parent quartic function. How can you determine the equation of the graph? So they're both pointing downwards. So that means it's an even function. So that means it's a quartic function, or x to the 4th. And because they're pointing downwards, it's going to be negative. Okay, so they're both down. So it's a negative x to the 4th. Okay. Now here's the center at 1, 5. Okay, so the point 0, 0, I started at 0, 0. I went up 5 and over 1. So it's a shift of 1 unit to the right. So that's -1. And then it's up 5 units, so +5. So negative x minus 1 to the 4th plus 5. Okay. So determine the equation of each graph as it relates to its parent cubic function or quartic function. Okay. So A is a cubic function. So this has been moved. It is an odd function. So odd function. So the parent graph, we're going to say, is x cubed. Okay. The graph is pointing up and then down, so they've flipped it. So f of x is negative x cubed. Okay. Now this graph, I started at 0, 0, has moved over to the right 2 and up 4. So that means g of x equals negative x minus 2, I moved to the right 2 cubed, okay, plus 4 because I moved up 4. This is a quartic function. So that means parent graph is an even function. So x to the 4th, both are pointing up. So that means that it's a positive function. So I didn't reflect it. It moved to the left 1 and down 3. So g of x equals x plus 1, because I moved to the left 1, to the 4th minus 3. All right, example 5, apply a transformation of a cubic function. The volume of a box in cubic yards is given by the function v of x equals x cubed. The post office lists permissible shipping volumes in cubic feet. Write a function with cubic feet as the units. So I'm going to replace x with 3x. Okay. So I'm going to convert the yards to feet. So volume of a box in cubic yards is given by the function v of x equals x cubed. The post office limits permissible shipping volumes in cubic feet. So I'm going from yards to feet. Okay. There are 3 feet in every yard. That's where the 3 comes from. So v 3 of x equals 3 of x cubed. 3 cubed is 27, x cubed. So the function that represents the volume of the box in cubic feet is v of x equals 27x cubed. A terrarium is in the shape of a rectangular prism. The volume of the tank is given by v of x equals x times 2x times x plus 5, or 2x cubed plus 10x squared, where x is measured in inches. The manufacturer wants to compare the volume of this tank with one that has a width 2 inches shorter but maintains the relationship between the width and the other dimensions. So I want to write a new function for the volume of the smaller tank. Okay, so v, and I have the original x measured in inches minus 2 inches shorter. So I'm going to substitute that in. So I'm replacing x with x minus 2. So I get x minus 2 times x minus 2 times x minus 2 plus 5. So when I substitute that out, when I work all that out, I distribute this 2 to everything inside. And then I'm going to simplify this negative 2 plus 5. So I get x minus 2 times 2x minus 4 times x plus 3, or 2x squared minus 8x plus 8 times x plus 3, which gives us 2x cubed minus 2x squared minus 16x plus 24. So the function that represents the volume of the smaller tank is v times v of x minus 2 equals 2x cubed minus 2x squared minus 16x plus 24. All right, so let's try it out. The volume of a cube in cubic feet is given by the function v of x equals x cubed. Write a function for the volume of the cube with cubic inches as the units. So I'm going from feet to inches. There are 12 inches in 1 foot. So I'm going to substitute 12x in for v, or in for x, 12x in for x. So this gives me 12x cubed, which equals 1,728x cubed. So for letter B, a storage unit is in the shape of a rectangular prism. The volume of the storage unit is given by v of x equals x times x minus 1, or x cubed minus x squared. A potential customer wants to compare the volume of this storage unit with that of another storage unit that is 1 foot longer in every dimension. Write a function for the volume of this larger unit. Okay, so the volume I'm adding 1, so v of x plus 1 equals x plus 1 times x plus 1 times x plus 1 minus 1. Okay, when I do that, I get x plus 1 times x plus 1 times x. Okay, so that gives me x squared plus 1x plus 1x plus 1 times x. X, and that equals x squared plus 2x plus 1 times x, which gives me x cubed plus 2x squared plus x. All right, so concept summary. Understanding polynomial functions. You have even functions or odd functions. So even functions, both the end behaviors are either positive or negative. They have degrees x squared, x to the 4th, or x to the 6th. Odd functions have a point of symmetry around the origin. For all x, f of negative x equals negative f of x. It has odd degrees, so x, x cubed, or x to the 5th, and its end behaviors are pointing in opposite directions. Okay. So translations, you can have the vertex move to the right, left, up, or down. Same with odds. So the graph of function moves to the left 5 units and down 2 units. So here's the original 5, 2. This even function moved over 4 and up 1. And that is the end of Unit 3, Lesson 7.